April 29, 2019. A radio telescope in the Australian outback locks onto Proxima Centauri, the closest star to our Sun, and picks up something it has no business. 5. Picking up a narrow, clean signal at 982 megahertz, the kind of signal that doesn't fall out of stars. The kind of signal that doesn't fall out of dust clouds, or supernovae, or pulsars, or quasars, O5, or anything natural we've ever cataloged in the universe. The kind of signal that, as far as we know, in 5, only one thing in the entire cosmos has ever been confirmed to produce: technology. Blythe, and it was coming from the direction of the only star close enough to us that, if there were someone there waving at us, we could almost wave back. The astronomers who saw it didn't tell anyone for over a year, not their colleagues, not the press, not their families. They sat on it, 5, because if they were right, they were about to upend everything. And if they were wrong, they were about to become a cautionary tale. This is the story of the most credible alien signal in modern astronomy. Might 5, the 2-year investigation that consumed some of the smartest minds in the field, and the answer that, depending on how you look at it, E5 is either the most boring or the most unsettling thing they could have possibly found. Let's back up. The telescope is called Parkes. It's a 64-meter dish in New South Wales, the same one NASA used to relay Neil Armstrong's first steps off the lunar module. In 2019, it was being used by a project called Breakthrough Listen, which is a $100 million effort funded by a Russian billionaire named Yuri Milner to do the most serious, most systematic search for extraterrestrial intelligence ever attempted. The project scans thousands of nearby stars across billions of radio frequencies, looking for a signal that doesn't belong. The problem with that job, the problem that has haunted SETI for 60 years, is that human technology is unbelievably noisy. Your microwave leaks, your phone leaks. Satellites are screaming overhead constantly, so the entire game of SETI is filtering out us to listen for them. And by 2019, Breakthrough Listen had filtered out trillions of signals. Every single one had a mundane explanation. Every single one, until April 29th. 5. The reason Proxima was being observed at all wasn't because anyone was looking for aliens there specifically. They were watching the star for flares. Proxima is a red dwarf, smaller and dimmer than our Sun. 5, but a violent little thing. It throws off radiation outbursts that would sterilize anything sitting too close. And around it orbits Proxima b, 5, a rocky planet roughly the size of Earth, sitting in what astronomers call the habitable zone, liquid water territory. The closest potentially Earth-like world to us in the entire galaxy, 4.2 light-years away, which in cosmic terms is basically next door. So Parkes was pointed at this star, sweeping the spectrum, when an undergraduate intern named Shane Smith was reviewing data months later and noticed something he wasn't supposed to be able to find. A signal at 982,002 megahertz, narrow, steady, drifting in frequency in exactly the way you'd expect from something moving on a rotating planet. It looked, in every meaningful technical sense, like a transmitter. Now here's why that mattered. Nature, as far as we understand it, it doesn't broadcast on narrow frequencies. Stars don't, galaxies don't, hydrogen clouds don't. When natural objects emit radio waves, they smear them across the spectrum like a flashlight through fog. But a transmitter, a radio, a satellite, a phone, a microwave oven, concentrates its energy into a needle-thin channel. That's the whole point of a transmitter. So, when you find a signal that's narrowband and not coming from Earth, you have by definition one of the most interesting objects in the universe in your data file. The signal was given a name, BLC1, Breakthrough Listen Candidate 1. 5. The first signal in the program's history that survived initial scrutiny, and it kept surviving. The team checked the obvious things first. Was it interference from a satellite? When they pointed the telescope away from Proxima, a procedure called nodding, where you swing off target and back, the signal disappeared. When they pointed back at Proxima, it came back. That's huge. Satellites don't care which star you're aimed at. If a satellite were leaking on 982 megahertz, it would leak whether you were looking at Proxima or at empty sky next to it. But this thing seemed to be locked to that one point in the heavens. Then they looked at the drift. Any transmitter sitting on a planet that's spinning and orbiting will appear to change frequency over time. A 5, because the planet is moving relative to us. That's the Doppler effect. The drift on BLC-1 was consistent with a source somewhere out there in space. 5, not down here on Earth. And then they looked at the timing. The signal appeared in a window of about 30 hours of observations. It didn't repeat. They never heard it again. And that, weirdly, is also what you'd expect from a real alien signal. Because why would extraterrestrials, if they exist, beam at us continuously on a frequency we happen to be watching at the exact moment we happen to be looking? 5. So they had a signal that passed every test they could throw at it. And the people in charge knew exactly what would happen if they announced it. They had all watched, decades earlier, the pulsar fiasco, when astronomers picked up a regular ticking pulse and briefly labeled it LGM-1, Little Green Men 1, before realizing they'd discovered a new class, of 5 of dead star. They had watched the WOW signal in 1977, a 72-second burst that has never been explained and never been heard again, get hijacked by every conspiracy theorist with a radio. They had watched the peritons at Parkes itself, mysterious bursts of energy that turned out to be the staff microwave oven. They knew. They knew the cost of being wrong in public, so they did something almost unprecedented in the era of leak everything science. They sat on it. For more than a year, a small team quietly worked the data, trying to kill their own discovery. And what they were looking for, I-5, the thing they had to find before they could responsibly tell anyone, was the alternative, the boring explanation, the microwave oven. In December 2020, the story leaked to The Guardian, and the world went briefly insane. Headlines about contact, speculation about Proxima b, by 5 Twitter threads explaining frequency drift to people who'd never thought about a Doppler shift in their lives. The Breakthrough Listen team, by 5, somewhat reluctantly, confirmed the signal existed and asked everyone to wait. The peer-reviewed papers were coming. The investigation wasn't done. And then, in October 2021, the answer arrived. 2 papers in Nature Astronomy, the most thorough analysis of a single radio signal ever conducted. And the answer was, it was us. The whole time, it was us. Here's what they found. BLC-1 wasn't a transmitter on Proxima b, it wasn't aliens. A-5, it wasn't a satellite. It was something stranger and more humiliating, which is interference from human electronics on the ground, possibly even on the telescope's own site, that had managed to mimic the signature of a deep space transmitter so convincingly that it took 2 years of forensic analysis to unmask it. The team eventually found dozens of similar signals, what they called lookalikes, buried elsewhere in the Parkes data, A-5, all at frequencies that lined up suspiciously with combinations of clock crystals and oscillators in consumer electronics, computer components, phones, power supplies. The frequency drift they had taken as evidence of a planetary source turned out to be reproducible by simple electronic devices in certain failure modes. The on-off pattern, the directional behavior, all of it could be explained painfully. Point 5 by terrestrial junk that had managed to find a path into the dish at exactly the wrong moment. What's wild is the level of detective work that took. The 5. The team had to develop entirely new statistical techniques to compare candidate signals against the background of electronic interference. They had to map the spectral signatures of consumer hardware. They had to essentially build a forensic theory of human radio noise from scratch. All 5, and in the process, they discovered something almost more useful than a real alien signal would have been. They discovered exactly how badly our own technology fools us. They discovered that the boring explanation, the microwave oven answer, Point 5 can pass tests we thought were unfakeable. They discovered that the standards of evidence in SETI need to be even higher than anyone realized. 5. So if you're listening to this and feeling a little let down, yeah, so were they. The lead author on the debunking paper described it as the hardest piece of work of her career, knowing the conclusion she was reaching, but 5, knowing what people wanted the answer to be and writing it anyway. But here's the thing I keep coming back to. The thing that I think makes this story actually important and not just a footnote. BLC-1 did exactly what a SETI signal is supposed to do. It made it through every existing filter. It survived a year of scrutiny. It forced an entire field to ask whether their methods were strong enough, and the answer turned out to be no, not yet. 5, and that means when the next one comes, and there will be a next one, the people watching will know more. Their filters will be sharper. I've Byte 5 that their false positive rate will be lower. The hunt is harder now, but it's also better, and there's a second thing worth sitting with for a moment. We have been listening seriously for 60 years, with ever more sensitive instruments, aimed at ever more stars. I-5 and the silence so far has been deafening. Some people read that as proof that we're alone. I'm 5, others, and I'm one of them, read it as proof that we don't yet know how to listen. We've barely scratched a fraction of the frequencies. We've barely scratched a fraction of the sky. We assume aliens, if they exist, would broadcast in radio. They 5 because that's what we did at our technological adolescence. But we stopped broadcasting like that decades ago, switching to lower power, encrypted 5 digital signals that, from light years away, would look indistinguishable from noise. Maybe everyone else has done the same thing. 5, maybe the galaxy is full of conversations happening, in formats we can't recognize, on channels we don't think to check. Point 5, and we're like someone holding a tin can on a string and wondering why no one is calling. Proxima B is still there, 4.2 light years away. A 5 spinning in the habitable zone of a star that throws tantrums of radiation. Whether anything is alive on its surface, we still don't know. The most likely answer, based on the physics, is no. Red dwarfs are brutal neighbors. A 5, but the most likely answer has been wrong before in the history of this field. Point 5 and BLC-1, even though it turned out to be nothing, was a reminder that the question is worth asking with everything we've got. A5, because the day we stop asking is the day we definitely won't hear the answer. If this kind of story is the reason you watch this channel, the slow detective work, the boring answer that's somehow more interesting than the exciting one, the way science actually works behind the curtain, do me a small favor. AA5, hit subscribe, drop a like, and tell me in the comments what you would do if you were sitting on a signal like BLC-1 for a year before you knew what it was. Would you stay quiet? Would you announce? Would you have hoped harder than the data could support? Because that's the real question this story leaves behind, not whether anyone is out there, but what we, down here, are willing to do with not knowing.